All right, today we start logarithms 4.3. This is day 1 of logarithms. And we're going to start with the warm-up because it's an important part of it. If I have an exponential function and I want to find the inverse of it, remember the inverse is where you switch the x and the y. So this would be x equals 2 to the y. And then the question is, how do we get to the y? Right? That's the problem we encounter. Well, logs are how we deal with the inverse, are the inverse of the exponential function. And so what we do is we take the log of b will equal x. So the y comes over here. The b is it's the base of the exponent, but then it's log base b, okay, because that's the inverse of x. And the expanded form of the logarithmic form is y equals log base b x minus h plus k. Okay, and same thing we discussed before, that your h tells you if it shifts left or right. Your k tells you if it shifts. Let me rewrite this so it's clear. The h shifts left and right. And remember, the h is the opposite of what's in with the x because it's a subtraction. The k tells you how it shifts up and down. Your asymptote for this one, okay, because it's an inverse, right? Our asymptote in an exponential form is y equals k. For logarithmic form, it's x equals h is our asymptote. Okay. So the best thing to do is just start working through some of these. So I'm going to come over here. And we have y equals log base 3 to the x. And remember, log base 3 is the same as 3 to the y equals x. And I like to do around the world. So 3 to the y equals x is the same thing as y equals log base 3 of x. When we set up our tables, we're just going to use ordered pairs. And for these, we just do 2 ordered pairs. And what's really important to remember is you start with 1, 0 and b, 1. Okay. So for this one, my b is 3. So the points that I'm going to use are 1, 0 and 3, 1. I don't have anything being added. I don't have anything being added or subtracted from x. So my asymptote is just going to be x equals 0 because I don't have an h. So it's going to be this. Okay. My points are 1, 0 and 3, 1, which means it's going up this way and then down this way towards my asymptote. My domain. This time my domain for when we were doing exponential functions, my domain was always negative to positive infinity. And then the range was based on your y asymptote. This time it's the other way around. My range is going to be negative to positive infinity. Okay, it goes negative and then this is going to keep going up and out to positive infinity. So this is negative to infinity to positive infinity. My domain is going to be determined by my x asymptote. So if I go from left to right, I don't have any values till I get to 0. So 0 is where I start, but it's with the parentheses because it approaches it but never touches it. And then out to positive infinity. And that's your graph. So let's try again. I've got log base 3 to the x plus 2. This plus 2 means that my h is negative 2. H is negative 2. So that means it's going left 2. So if I start with the parent function of the log base 3 would be 1, 0 and my b, 3, 1, right? Because that's what we start with. We start with 1, 0 and my b, 1. And then for both of these, I'm going left 2. So that means that's my x is going left 2. So that means I'm subtracting 2 from my x. So 1 minus 2 is negative 1. 3 minus 2 is positive 1. And my y's don't change because I don't have a k, so the y's not changing at all. So this is left 2 means I'm subtracting 1, or I'm subtracting 2 from my x. So now I've got negative 1, 0. Let's graph this. Negative 1, 0. 1, 0, and then 1, 1. My asymptote is going to be x equals whatever my h is. It's always the opposite of what's in here. So my asymptote is x equals negative 2. And it's a vertical line. These are my 2 points, which means it's coming up and out this way and down towards my asymptote. My domain, going from left to right, is based on my asymptote, so I don't have any values until negative 2. It's a parentheses because it's not including the negative 2, and then I have values all the way out to positive infinity, and my range is going to be negative to positive infinity. Okay, let's try another one. This is also log base 3. Okay. And this time I have a k. I don't have anything happening with x, but my k is plus 2, which means it's going up 2. So if my original, we always start with 1, 0, and my base 1. 1 comma 0 and base 1. And now this time my y's are changing, and I'm adding 2 to my y's. So the 1's are not going to change. But this time my y, I'm adding 2 here, and I'm adding 2 here. 0 and 2 is 2, 1 and 2 is 3. My asymptote, I don't have anything, I don't have an h, so my asymptote is x equals 0. So it's going to be down through here. And then I have 1, 2, 3, 3, and it's going up and up this way, and then down towards here. Again, your domain, left to right, is based on your asymptote. So it starts at 0 and goes to positive infinity. Our range is from bottom to top is going from negative to positive infinity. Okay, next one. This one I have a negative in front of the log. That means that we are going to reflect over the x-axis. If I had a negative on the x on the inside of the log, that would be reflecting over the y-axis. But we're reflecting over the x-axis. And I don't have an h, but I do have a k, and so it's going up 2. And so I've got a couple of shifts here. So my parent function would be 1, 0, and then my base 1. My base is 3. I have a log base 3. First, when I reflect, it goes over x.